for our special guest today, who is Kelly Beatty, senior editor at Sky and Telescope magazine. Kelly is a passionate advocate for the night and insists that you do not need a PhD to appreciate all that astronomy has to offer. I should say that Kelly is also a past IDA board member and a great friend to IDA, and someone I personally really enjoy talking to. So I'm so glad you're here today. Thank you, Kelly.
Hey, Amanda, thank you so very much. It's great to be with you. Thanks for that introduction. I want to let everybody know that there's been a week-long just parade of great presentations on all different topics of the night sky. And I'm going to be showing you a little bit of the evening sky and sort of the science behind some of these stars. But I want to call your attention to a couple of the previous presentations, one by Tracy Bearden earlier this week, a crash course in astronomy. And of course, IDA's own John Barentine, who was, his lost constellations are constantly fabulous. John, I was particularly impressed by Custos Messium, the backdoor homage to Charles Messier, the French comet discoverer. So what I'm going to do today in the brief time we have is kind of take you on a walk through the evening sky. And I'm using a program that I highly recommend everybody get, either for your desktop, your iPad, your phone, whatever. It's called Stellarium, the word stellar, S-T-E-L-L-A-R, and then add I-U-M, Stellarium. It's free, it's open source, and it's the most intuitive simulation of the night sky that you're ever going to find. And so, Amanda, will you just confirm that you're seeing the beautiful evening sky?
Yeah, we can see it. Thank you.
All right. So what we have here is sort of the last vestiges of the winter stars, and there are many, many bright stars in the wintertime, and our view is a little bit crowded right now because we have the moon and Venus in view. So I'm going to take a couple of seconds here just to talk about the moon. Stellarium makes it very easy to zoom in. The moon is about 3 days past full, and in fact, this particular new moon and the thin crescent that you're seeing in the sky was used by the Islamic culture to determine the time of Ramadan. And that began yesterday when this crescent moon was first visible in the evening sky. Now, if I take that moon and I click through one day at a time, oops, I need to center it there. There you go. And I click through one day at a time, day by day that you see the moon is getting more and more illuminated. And it's also moving farther east in the sky as seen at sunset. And that has to do with the moon's movement around us, around the Earth in its orbit. I have to say, I'm not going to spend much time on this because the moon is one of the moon and its phases and its motion is one of the most difficult things to understand. But I have a prop, and I don't know if you can put me back on screen, but this is a plastic ping pong ball or golf ball. And what I want you to do over the next couple of nights, go out on a clear evening before the sun sets, just a half an hour or so that the sun is still in the sky, and use that ping pong ball and move it across the sky as if you're mimicking the motion of the moon. And you can even put it up right next to the real moon in the sky. And what that does is the sun will illuminate that ball in the same way that it's illuminating the moon itself. And so that will sort of drive home to you how the moon's phases occur. It's not at all the Earth's shadow. It's actually the fraction of the moon that we see. The moon goes around the Earth and goes from new moon to new moon in about 29.5 days. So we call that a lunation. The words moon and month are related for obvious reasons. I'm going to skip over here to the one planet we have in the evening sky. I'm not going to say too much about it. Right next to the moon right now this evening is the planet Venus, which is strikingly bright. It doesn't look like a big spot like this screen shows it. It's a pinpoint of light that is, right now, Venus is the brightest that it can ever get in our sky. It's by far brighter than any of the evening stars. It is that bright for a couple of reasons. One is Venus is closer to the sun than we are, so the sunlight on its surface is more intense. It's also only about 40 million miles away from us right now, which is really close as solar system distances go. So it looks, it's big and bright in our sky, relatively speaking. And then finally, Venus is a planet with a cloud deck that completely surrounds it. It's as if the Earth were completely overcast all the time, and those white clouds reflect a lot of sunlight to us. So that's why Venus is so bright. That's a talk for another time. So I'm going to back out here and just show you a couple of things. You want to go outside and look soon after sunset, about a half an hour, 45 minutes, and look to the west in a way that's unobstructed. Get away from trees and buildings in the way, because I'm going to call attention to something called, it's to the lower right of Venus in the sky. It's called the Pleiades star cluster, and you see it here. It's sometimes called the Seven Sisters. In Japanese, it's known as Subaru. In fact, the car Subaru has a stylized star cluster on its license plate. And, you know, the Pleiades are quickly about to disappear from our view, but I want to mention these to you because there's actually a couple of thousand stars here. We can only see a handful with the naked eye, or, you know, a couple of dozen through binoculars. This is a cluster that we call an open cluster. These stars all formed together roughly 100 million years ago from the same cloud of interstellar gas and dust. And the reason I bring this to your attention, first of all, it's beautiful to look at through a telescope or binoculars. It's like diamonds on black velvet. But this is probably the way our sun began. Now you say, well, Kelly, our sun is a star all by itself. Yes, that's true. But the smart money is that when our sun was born 4.5 million years ago, it had a lot of siblings that all formed from one big cloud, and that they were actually relatively close by. The situation with that cluster and with the Pleiades too is collectively they don't have all those stars together, even though they're relatively close to one another, don't have enough gravity to keep the cluster intact. And so in time, the Pleiades stars are going to all drift apart, just like 4.5 billion years ago, our sun and its siblings drifted apart. Heavy stuff there. Okay. So, Amanda, I can't see the chat. So do we have any questions yet? If not, I'm going to move on.
Kelly, I think you can move on. We'll monitor the questions, and anyone following along, please do post your questions in the chat wherever you're watching, on Facebook or YouTube. We'll keep track of them, and we'll come back to them after you're finished.
Yeah, that's right. It's a great time. So when I say the winter stars are disappearing, there's no more famous winter constellation than Orion, which is just about to sink in the west. And one of the things that Stellarium does really well is that it allows you to label things. Now, the stick figure version of Orion has Betelgeuse in his armpit up here at upper left, and down here is Rigel. Let's see, Rigel isn't quite labeled there. It's the bright one down at the bottom near the horizon. Betelgeuse is an interesting star. It's a very bright star in our sky, and the reason it's so bright is, well, it's a red supergiant. It's actually about 100,000 times the brightness of our sun, our own sun. It's 500 light years away. So when you think about it, the light that's reaching us from Betelgeuse left the star itself in the year 1522, plus or minus. That was decades before the invention of the telescope, and that light is only reaching us. So as you look out into the night sky, the stars that you see are essentially time machines. They are telling us that what the light was like when they left. Now, as you look into the night sky, there's a couple things I want you to notice about stars in general. First thing is, they're not all the same brightness. Some stars are bright, some stars are dim, and that's a good thing, because otherwise the night sky would be pretty boring if all the stars were exactly the same brightness. There are two reasons why some stars are brighter than others. Like in the case we have here on the screen, Betelgeuse, which is at the top of Orion, and then over to the left, just above the southwest, I'm bringing it to the center now, is the star Sirius. Sirius and Betelgeuse are both very bright stars, but they are bright for different reasons. Stars can be bright for two different reasons. One is some stars are just closer to us than other stars. So I mentioned that Betelgeuse is 500 light years away. Sirius is only 8 light years away, 8.5. And so Sirius looks bright, and in fact is the brightest nighttime star because it's so close. But the other reason that stars can be bright is that they're just brighter than our sun. Maybe I mentioned this. Betelgeuse is 100,000 times brighter than our sun, and so even though it's a lot farther away, it looks bright in our sky because it's so insanely bright. Now, scientists have been really fascinated with Betelgeuse in particular the last 6 months, because about last October, it started dimming. It started getting a lot dimmer than it actually normally is. It lost, I don't know, more than half of its brightness and became kind of just a pale version of its former self. And astronomers couldn't figure out why. They wondered, maybe is Betelgeuse in the first throes of becoming a supernova, which it will someday. And it turns out Betelgeuse went through this kind of dimming, and then it has come back. It's now nearly at its full brightness. And what astronomers think happened was that Betelgeuse kind of had a coughing fit, if you will, and shed some of its outer layer that went off into space like a big bubble. And as it went out into space, it cooled and solidified into tiny little dust particles. And so that created a kind of shroud around the star that caused it to dim. Now, looking at Betelgeuse, we can't tell that from just looking at it because it's just a point in the sky. But with the powerful telescopes that astronomers have, they were able to see changes in the character of its light that led them to understand finally what this dimming is all about. It's a very unusual circumstance. It hasn't happened before to Betelgeuse that we know of. Now I'm going to go a little bit farther here. Above Venus, to the upper right, above the horizon is another bright star called Capella. Capella's a very interesting star. To the eye, it has a kind of yellowish white color. It's very similar in color to what our sun would be if we could see our sun from very far away. But Capella is very deceptive. It's not just one star. It's actually 4 stars, a quadruple star system. And so when you look at Capella, our eye sees it as just one bright star, but it's actually 4 stars in orbit around each other, 2 of which are very much like our sun. They're roughly the same size and temperature as our sun, in orbit around each other. And so we can't see that by eye, but Capella is one of these stars with a secret, if you will. Now I'm going to go a little bit farther to the north, since time being of the essence. I'm going to swing around to the north and zoom out just a little bit. And I hope you can see up here near the top that famous Big Dipper, right? It looks, let's see, let's add a label here. Right. The Big Dipper is actually part of a constellation called Ursa Major, which you see near the top. I'm going to zoom in on it a little bit here. Right now, Ursa Major is the big bear, the bigger bear, is almost directly overhead and flying upside down. But inside the Big Dipper, inside Ursa Major are these main stars here that form what we call the Big Dipper. And so the Dipper is not a constellation. It's what astronomers call an asterism. And we know it as the Big Dipper. In other cultures, it's known as a plow. It can be a ladle. I can also look like a shopping cart, depending on the time of the season. And that's an important point. You know, you see stars, and we know, especially if you've watched some of John Barentine's presentations on the lost constellations. Constellations are a construct of whatever culture you happen to be living in. The constellations that we have largely come from Western European culture, and there's some that have come from Islamic culture. But in Asia and Polynesia and Finland and Indonesia, there are different kinds of constellations made out of the same stars. One thing that's very interesting about the Big Dipper, I'll get rid of the little symbol here. It was known as a ladle, like a big scoop with a handle on it. And there is a story that I want to just relate momentarily here, that in slave times in the South, the slaves had a song called "Follow the Drinking Gourd." Uh, Follow the drinking gourd, for the old man is coming to carry you to freedom if you'll just follow the drinking gourd. And, you know, slaves sang these songs to each other on the plantations in the South, and sometimes they were coded with messages. And so there's a school of thought, it's controversial a little bit, that the drinking gourd in this song was the Big Dipper. And because the Big Dipper is in the north part of the sky, as seen from the southern states and everywhere in the United States, the thought was that if slaves wanted to escape to the north along the Underground Railroad to freedom, if they just kept the Big Dipper in front of them, regardless of the time of the year, they would eventually make their way to some of the northern states. Well, as I said, it's a little bit controversial, but the Big Dipper does have value to us as a kind of Swiss Army knife of the sky. Let's see, I'm going to leave. I think you cannot see my cursor, but you can see the labels. Is that right, Amanda?
Yes.
Okay, so I've got Ursa Major right over the top of the Big Dipper, and the Big Dipper is kind of upside down right now. A bit of American folklore is that the Big Dipper is upside down and it's depositing spring rains on all the crops. If you follow the two brightest stars of under the big one immediately under Ursa Major there, and then the one to its lower left, those are called the pointer stars. They're on the lip of the overturned ladle, and if you follow them to the lower right, follow them to the lower left, you eventually reach a star. Let's see, I can click on it. This star, which is Polaris, the North Star. So, I can click on these stars. Okay, so here are the Big Dipper stars. Let's go back. Here are the 3 stars in the handle. And then these are the 4 stars of the bowl here. And if you follow these 2 stars to the lower left, you eventually get to this star, which is the North Star, Polaris. Polaris is nothing special as stars go. There are about 50 stars that are brighter in the sky. People think, oh, the North Star has to be the brightest star in the sky, but it's not. It's a pretty ordinary star, and it just happens to be that if you made a line through the Earth's spin axis and extended it out into space, it would come very near the Big Dipper, and very near Polaris. Now I'm going to kind of, wrong CL. I'm going to show you that. This is a grid that shows you the center of this grid is the spin axis of the Earth's rotation extended out into space. And so it passes very near Polaris. So if you can find Polaris in the sky using the stars of the Big Dipper, you can therefore find where north is. And that's obviously very handy for navigators, but more than that, the altitude of Polaris above the horizon, you can see how high it is here. From here in Boston, Polaris is about 45 degrees above the horizon. You can see that, right? See that scale? 42 degrees, 43 degrees. That is how high above the horizon Polaris is, and that is very close to the latitude of Boston. So for a navigator, no matter where you are, if you can see Polaris, you not only know the direction toward north, you can figure out what your latitude is on the Earth. Very handy. I'm going to go back to the Big Dipper and show you 2 more things, and then we're going to call it a day and see if people have questions. All right, so this Big Dipper, here's the Dipper stars again. We've shown you that the 2 front stars will point the way to Polaris down here, but you can also follow the stars in the handle arcing toward the northeast and east to a star called Arcturus. Arcturus is a very bright, also a red giant star that is, the name Arcturus means follower of the bear or guardian of the bear, depending on your interpretation. So just to remind you, here is the bear up here. This is the end of the star there that I've circled marks the tail of the Ursa Major, the big bear. And Arcturus is part of the constellation Boötes, the herdsman. And and Plowman, and Arcturus is in folklore is a star that follows the bear around in the sky. So if you follow that arc of stars that form the Big Dipper's handle, they will lead you to Arcturus. And let's see, I can make that happen this way. There you go. It will lead you to Arcturus very easily. And then if you keep going, follow that arc a little bit farther, it will lead you to another star of the springtime called Spica or Spica, depending on how you want to pronounce it. Spica means ear of grain, and you can see the figure there. That's Virgo, the maiden. She is a very common constellation, one of the harbingers of spring in the northern hemisphere. And Spica is the brightest star. Now, Spica, unlike some of these other stars I've been telling you about, is a blue-white star. Rather than having a reddish tinge like Arcturus or Betelgeuse, Spica is a blue-white star, and it's blue because it's so hot. Astronomers long ago realized that the colors of stars gave us some clue as to their temperature. And in the case of Spica, that blue-white color is telling us that Spica has a surface temperature of 45,000 degrees. That's roughly 4 times hotter than the surface of the sun. Who knew stars had color? And so that temperature is telling us something about the lifetime of this star Spica. Blue-white stars tend to burn very hot, and they run through their fuel, the hydrogen that fuels their fusion, that gives them their light and heat, in very rapid time. So Spica, as a star, is not going to last very long. Some of the other stars I mentioned will last much longer. Our sun, for example, is already 4.5 billion years old. Spica is not going to last anywhere near that long. It's got a lifetime measured in probably at best 100 million years. And when that happens, it's going to, let's see, I want to look to see if it gives me its mass. It has 20,000 times the luminosity of the sun. I believe Spica, once its life ends, will end as a supernova. Now that's the thing about stars. As I said, the colors tell you something about their temperature and their lifetimes. And I'm going to go back to this evening sky here for a second and show you all these stars again before I close. When we look at stars and we see their colors and their temperatures, astronomers know something about the lifetimes of these stars. It's like, I want you to all imagine that you're seeing your birth certificate. Maybe you've never seen your birth certificate, or some of you probably have. You know, when you're born, it records important facts about the day you were born, the time you were born, how much you weighed, how long you were, what your parents' names and where you were born. Now, imagine if in addition to that information, your birth certificate had, it said how tall you would get to be, what color your hair would be, whether you would get fat in your old age, what you would die of, and when you would die. Imagine if your birth certificate had all that information on it. Well, when we look at stars, that's what we know. We know from a star's mass what its lifetime is going to be. We know, for example, that our sun doesn't have enough mass to ever become a supernova. It's just not massive enough. It's going to die in its old age. It's going to get a little cranky. It's going to shed its outer layers and eventually end up as what astronomers call a dim former self, that its core will be a white dwarf. But if the sun had, for example, 8 times more mass, it would end its life as a supernova. And if it had 25 times the mass that it has, it would end life not only as a supernova, but then its core would collapse and form a black hole. And so as you look out into the nighttime sky, be it wintertime or summertime, know that each of these stars that you see, regardless of how much light pollution you have in your sky, each of these stars that you see has a story to tell, and it tells that story to astronomers, and it tells that story to every day to us as just part of a tapestry of the night that brings us beauty and makes us think big thoughts. I just want to close by saying, when I was growing up in Central California many, many years ago, I didn't have very much light pollution. And I would walk out into the nighttime, especially in summer, and see all those stars arrayed, especially the Milky Way. And it caused me to really imagine what it was like out there in the universe. Where was my part in that universe? What are the big questions? How did the universe begin? And honestly, it put me on a path that took me to astronomy, to Sky and Telescope, where I continue to be a part of the storytelling that goes on there about astronomy and stargazing. And so I hope this has been a little bit of a help to you. I just want you to appreciate that while the sky itself is beautiful, every one of those stars has a story to tell, and some of those stories are pretty interesting. I for one, am going to go out and look at Capella tonight and imagine 4 stars in that one spot. So Amanda, I think that's it for now. Let's open it up to questions if there are any.
Well, thanks, Kelly. It's a lot of fun hearing your perspective and the stories of the different stars. And appreciate you being here and helping us appreciate what we can see at night. I had a couple of questions, and we'll be collecting questions from people posting as well, and we'll get to those in just a second. One question I have, you talked about Polaris being the North Star. And one of the reasons that I'm here hosting today is because I don't have a background in astronomy. I don't know much about astronomy or amateur astronomy, and so it's a lot of fun learning from you, and I hope that everyone can learn along with us. So you talked about the North Star, and I'm wondering about how visible that is around the world. IDEA is an international organization, and we try to think a little bit about both the northern and southern hemispheres. And so is there a similar star in the southern hemisphere?
There is not. That's a great question, and one I get a lot. And some people might know that the North Star is at the center of this grid. Oops, I keep clicking the wrong one. Is the center of this grid only by accident. The Earth over time wobbles as it spins with a period of about 26,000 years, and over that time, just like a top, the spin axis of a top wobbles and points in different directions, the spin axis of our Earth points in different directions too. So we're just fortunate that that star Polaris is in the center of the grid right now. If you were long ago in Egypt, for example, this star right here, nope, that's a satellite. It's definitely not what I want.
Yeah, I don't think a satellite would have been there.
No, it would not have. Here we go. Where are you? I'm looking for Thuban. John, help me out here. It's not that one. It's definitely not that one. I'm looking for. Oh well, one of the. I thought it was this one, but it doesn't. It's not coming up as that name.
Well, it's nice.
Anyway, that was the pole star when the pyramids were being built, and so a lot of the alignments from thousands of years ago don't make any sense now. So to your point about the southern hemisphere, I'm going to do something really wild and wacky here. I'm going to get rid of the Earth, and we're going to swing around. We're going to go into the southern hemisphere, and we're going to go around the southern pole. And there'll be some familiar things here, right? I'm bringing to the center. Here's the Southern Cross, right here. Here are Alpha and Beta Centauri here. And when you go to the middle of that grid and look really, really closely, there is no bright star there whatsoever. And so consequently, when you're a stargazer in the Southern Hemisphere, you have your work cut out for you if you want to align your telescope, for example, so it can track the stars. We have it much easier here in the north.
So one other question about the Southern Hemisphere, a lot of people talk about the Milky Way being different or more beautiful in the Southern Hemisphere than you can see in the Northern Hemisphere. Why is that?
Okay, let me show you why. I'm gonna just click a couple of things off here. I'm gonna bring back the ground. Okay, so here's the southern horizon. We're gonna fast forward in time to late August. And you can see this cloud here between the moon and Jupiter, the cloud sort of extending vertically through the screen. That's the Milky Way. And right about here is the center of the Milky Way. That is, if you flew, 50,000 light years in that direction, you'd go to the center of the Milky Way. But because it's so low to the horizon for most of us, you can see the horizon there. It's only 15 or 20 degrees from me up here in Boston. The farther south you go, the higher in the sky that Milky Way becomes. So I'm going to get rid of the ground again. And I'm going to imagine that I'm now deep. Oops, that's not working. I'm now deep in the southern sky. So there's that southern pole again. You can see that the center of the Milky Way up here, the flashing box, is not all that far from the southern pole. So when you see the Milky Way from the southern hemisphere, it's much higher up in the sky and it's much more dramatic. So the kinds of photos that like Babak Tafreshi takes when he goes to Chile, or if you ever get a chance to go to Chile, it's fantastic. The Milky Way is directly overhead. It appears much brighter and much more dramatic.
Yeah, thanks. We're here with Kelly Beatty, who is a senior editor at Sky and Telescope magazine, and he's talking to us about how to appreciate objects in the night sky. So if you have questions for Kelly, please go ahead and post them in the chat box, wherever you're watching from, on YouTube or Facebook. We're monitoring those questions, and we have one from Hina on Facebook, and she says, you can easily spot Venus in the sky, as we know that is the brightest planet, and it appears like a bright star in the sky. Are there any other celestial objects that we can spot easily and identify?
Okay, so let me go back to the evening sky here that we have. So if you use Venus, Venus is a planet, and so Venus doesn't shine by its own light. It shines because sunlight is reflecting off of it. The same with the moon. I have told you about some of the stars that are in the vicinity of Venus, including Capella to the upper right there. These Sirius. What I would direct your attention to is Sirius down here, which is to the lower left of Venus, down near the horizon, the southwest horizon. That is the brightest star in the nighttime sky. And so Sirius is an interesting star because it's so close. It's only 8.5 light years away. And that means it's merely 50 trillion miles away, which is pretty close as stars go. But I want to, since I'm a lover of science fiction, I want to swing our attention. I'm going to go back to 8:30 at night, which is when it first gets dark. This is for now. And I'm going to swing way over to the northeast horizon. So once you've seen Venus, I want you to turn around, do a 180, and look toward the northeast horizon, and you're going to see this bright star here, Vega, or Vega, some people say. Vega is an interesting star for a couple of reasons. One is, I mentioned earlier that stars have different brightnesses, and this has been known since antiquity, that stars have different brightnesses, of course. But it was Hipparchus, who was an ancient Greek watcher of the sky, who first came up with the notion of assigning numbers to measure the brightness of the stars. And he has said that the very brightest stars were stars of the first magnitude, like winning first place in a race. And the second brightest stars were second magnitude, and so forth. And this became the anchor for what astronomers currently use, the magnitude system that we use to gauge the brightnesses of stars. And we still use that word magnitude as a gauge. So I have circled here Vega because rather than just being a kind of loose definition, astronomers took Vega, the star Vega, and they made that the anchor for the magnitude system. Can you see the information on the left-hand side of the screen?
Yeah, we can see it.
Okay, the second line says magnitude 0.00. And so astronomers used Vega as the anchor for their magnitude system. So stars that are fainter have a higher number, like fourth or fifth or sixth magnitude. Sixth magnitude is about the faintest star you can see by eye. And that's roughly 250 times fainter than Vega is. But the other thing I want to mention about Vega, which is so cool, Vega is a summertime star and it's just now starting to rise. If any of you have seen the movie Contact, which starred Jodie Foster, I think it's about 20 years old now, one of the best science fiction movies ever made. And it involves the discovery of an advanced civilization on a planet surrounding Vega. And I don't want to say any more about it because that would be a spoiler. But that star, Vega, right, just now rising in the northeast, is the pivotal star in the movie Contact, and you'll just have to go find out why.
Don't spoil it for us. We're all rushing to go watch it. All right. So here's a question about Stellarium. There, we have Gunhan Attila on Facebook says there's a lot of stars on Stellarium that don't have a name. What does that mean? Are they unknown stars, or are they just too far away?
Ah, that's a very, very great question. So if I were to, let's see if I can do something quickly here. Sky, stars, labels. I'm gonna add lots of labels here, okay?
Okay.
So the stars, not all the stars have names. You're absolutely right. And there are only 200 or 300 stars that have what you would call common names, like Polaris or Betelgeuse or Castor and Pollux. And the reason for that, let's go over to the, you can see some of the stars here of Orion, Betelgeuse and Rigel and these. Those are common names, and there are only a couple of hundred of them. I mentioned, for example, that Capella, way up here, is a derivative of the word for goat. And so some stars do have names. A lot of the names that we have come to us from Arabic. So for example, El Nath and Al Hayna that you see here in Arabic, the prefix AL, like Al Jazeera, Al Qaeda, means the. And so the is often used as a prefix, Al Gol. There's one here that will come up a little bit later in the oops, that's not what I wanted to do. Here we go. Let me see if I can find it quickly. No, I can't. All right. So only a couple of hundred stars have common names, but all stars have a designation of one kind or another. When I add, you can see now that I'm going to zoom in on a couple of stars, for example. Here's a star. Let's find one with a name. I'm going to kind of fish around here for a little bit because we've got time.
Who catalogs all of the stars? How do I see that?
Okay, yeah, that's all right. So here are stars in the constellation Perseus. Okay, for example, which is a kind of a fall star catalog, and I'm looking for. Can't see the forest for the trees here. Pardon me for just a second. I'm going to go back to my little scale here. Slide this back. Let's find a star. So for every star that has a name, that star might have a 2 or 3 other designations. These stars, for example, let's go Mirfac. That's a good one. Okay. That's a common name. That star is also known as, you can see in the upper right, it's Alpha Persei. It is the brightest star. It is the alpha star in the constellation of Perseus. And he has all of these other designations that you see. And so a star might not have a common name, but it will have a designation of some kind. either a Greek letter name that designates its brightness within a constellation. This SAO number here, that's the Smithsonian Astrophysical Observatory Catalog. The HIP is the Hipparcos Catalog. The HD here is Henry Draper Catalog. And then if you run out of those catalogs, this last one here, the WDS, that alphanumeric soup there that you see is a combination of the coordinates for that star. So even if it doesn't have any other kind of designation, you could designate it just by its coordinates, and astronomers would know which star you're talking about.
It's interesting to see all of the different codes to show that the stars don't belong to anyone. Right? There's interest from so many different people and groups and history. It's fun to see.
Yeah, and just a quick aside here. Some people online here might remember that some years ago there was a great controversy. John will certainly remember this, over a company that would allow you to have a star named after you. And so the International Star Registry was the name of the company. And for $50 or $75, they would name a star after you and send you a plaque and a certificate that this star was named, Amanda, or whatever you wanted it to be. And astronomers hated that because no one except the International Astronomical Union has the authority to name stars. But the IAU itself was not naming any stars, not even the common everyday stars that we know, Betelgeuse and Polaris and those everyday Capella. Those stars were never officially sanctioned by the IAU until about 3 years ago. And then the IAU realized they were onto something. They started naming stars themselves. And so many of the star names that we've been using for hundreds of years are now official because the IAU has made it so.
Kelly, that's funny. You answered. We had a question come through about how do astronomers get to name stars? Can we name them after our loved ones? And you answered it for us, so we didn't even have to.
I'm gonna riff on this for just a little second here. I'm going back to the constellation Perseus. Here's and next to Perseus is the constellation of Cassiopeia. Cassiopeia is a very well-known constellation because it looks like this kind of zigzag W or 3 or M, depending on what time of year. And I want to call your attention to this star in the center that's named Navi. Navi is not an official name for this star. And it's on here because during the Apollo mission, the astronauts had to be able to navigate in case of an emergency, navigate on some of the brighter stars in the sky so that they could figure out what the orientation of their spacecraft was. And the Apollo 1 crew they actually trained in Griffith Observatory Planetarium in Los Angeles, California. And some of the stars that they wanted to use as navigation stars didn't have these common names. And so they conspired with the staff of the planetarium to name 3 of the stars after themselves. So Navi, if you look at that right here, I'll zoom out. Navi is the name Ivan, I-V-A-N, spelled backwards. And Ivan is the middle name of Virgil I. Gus Grissom. And the 2 other stars that got named were called Rigor, which is Roger, which is first name of Roger Chaffee, spelled backwards. And the third one was Denoces, D-N-O-C-E-S, which is second spelled backwards. And that was for Edward White the second. And so these astronauts conjured up names that entered into the astronomers' lingo as real star names, and they were completely fictitious and made up by themselves.
Kelly, how do you come across this information? What are your sources for learning the history of these stars and constellations and asterisms?
Sure. So There are a couple of books on the history of star names. I don't have one to show you right now because I'm in the middle of redoing my library, so they're all boxed away. There are a couple of authoritative works on the history of the names of stars. Even if you go to Wikipedia and look up a star name like Betelgeuse or Polaris, it will give you the history of the name of that star. So that's one way you can do it. Me, myself, Amanda, I have been on the staff of Sky and Telescope for 45 years. That's a long time. It's a lifetime of, it's one whole giant career. And, you know, it's my job to kind of know this stuff. And to be honest with you, astronomy as a science has become too big for any one person to know everything. Mm-hmm. So, for example, you had Ed Krupp on earlier this week, mm-hmm. and Ed is a specialist in the way that other cultures have seen stars and imagine that the universe over the heavens. You've had, astronauts and other astronomers. My little slice of the pie, it turns out, is the solar system. My specialty is the solar system. If it doesn't go around the sun, I don't really know about it or care about it. But if it does go around the sun, the planets and their moons and comets and asteroids, then I really specialize in that. And maybe to just impress you with my knowledge, in 3 days, you're going to be hearing a lot about an asteroid called 1998 OR2. Now, that designation tells you that it was discovered in 1998. It hasn't actually been named as an asteroid yet. And you'll see news reports about this big asteroid. It's fairly big as asteroids that come near the Earth go. I think it's roughly about a third of a mile across. And it's going to be coming close to the Earth, which in this case means about 4 million miles away, which is not very close at all. In astronomy terms, you know, that's 25 times the distance of 16 times the distance of the moon from the Earth. So it's really kind of far away, but it will be in the news, and you heard it here first.
From Kelly Beatty. So Kelly, for somebody who is not familiar with the solar system or what to look for in the night sky, where should they start?
Yeah, so a couple of things. Just let me put in a plug here for Sky and Telescope magazine and our website, skyandtelescope.org, where we have lots and lots of resources for beginning stargazers. We have an interactive star chart that you can find. You can call up what the sky looks like for your place and time. I want to reiterate for those who maybe came later, I've been showing you a program called Stellarium. You can see it up there in the upper left-hand corner of the screen. It's a free program, stellarium.org. You can download this and do all the things that I've shown you. It's very intuitive. At the school I used to teach at, we had our fifth graders running this on all of their computers. So, I mean, if you're as smart as a fifth grader, or maybe you are a fifth grader, that's what I would recommend. Mm. But skyandtelescope.org has a lot of information for beginning stargazers. And in particular, it helps you understand what is in the sky this week, this month. We have a weekly column called Sky at a Glance. And I actually do a monthly podcast called Sky Tour. So if you go to our website and in the search box, click Sky, type in Sky Tour. It's like a 10-minute tour of the evening sky, mostly, that you can just listen to. You don't need any equipment, any telescope or binoculars. Just listen to me and I will take you on a 10-minute guided tour of what's up in the sky tonight.
We've had a couple of people comment how much they enjoyed that podcast, so I'm glad you were able to bring that up. And
thank you very much.
And you also mentioned Sky and Telescope's Sky Chart, and IDA put together an activity for people to learn how to use the Sky Chart. If you haven't yet using that Sky and Telescope Sky Chart, that's at idsw.darksky.org. On the Activities tab, you can find some activities to do by yourself or with your family, and learning how to use the Sky Chart is one of those things that might help you locate some of the things that Kelly has been talking about today. or listening to his podcasts, become familiar with what he's talking about. So thanks, Kelly. We have time for just a couple more questions, and there's lots of stuff coming in through Facebook and YouTube. But if you have other questions, please post them, and we'll try to get to them. Someone is asking about the moon, and I know you started your conversation by talking about how the moon is how people in the Islamic world measure time, and I think that's an appropriate place to say Ramadan Mubarak to anyone who's watching from one of those countries or anywhere in the world that's celebrating Ramadan. We did just see the crescent moon return to the night sky to begin that month of fasting. And there's a question here about, is the visible part of the moon the same if you're at different latitudes? Can you see it the same way no matter where you are in the world?
Oh, such a terrific question. So I'm zooming in on the moon here, and you see that the crescent is pointing toward the sun. That is, it's on the, this is that slice of the moon that you see lit in the lower right hand is the part that the sun is illuminating. If I were looking at that same moon from, say, Australia, and actually let me I think I can quickly pick a new location. Let's go to Santiago, Chile. Santiago, Chile. There we go. Let's go to Santiago, Chile, and find the moon in the sky. And it's a little later there. So there's the moon. Now we're going to zoom in on the moon again, except now we're in the southern hemisphere. And look, the part of the moon that's illuminated, it's the same moon, but it's rotated because we're on a different place in the earth. So it's kind of a trick question. Yes, we all see the same moon, and we all see it illuminated, the same part illuminated. But depending on where you are on the earth, it can be turned one way or the other. Let's go back to Boston, and I'll do one more thing here. Boston. And by the way, you can see how quickly you can kind of switch things around here. Let's go to find the moon in the sky. There it is. So I'm going to go ahead in time. I'm going to follow the moon, but I'm going to go ahead in time to where the moon is nearly full. And now you can see that it's rising over the eastern horizon, the southeast horizon, okay? Now, what I want you to do, we're going to step through 1 hour at a time. I want you to notice that on the left-hand side of the moon are a lot of dark markings, kind of blotchy. And on the top, there's this one little isolated circle. Do you see that, Amanda?
I see it. Yep.
All right, now we're gonna center the moon, and we're gonna step through hour by hour. This is the way the moon would look to you in the sky. And what I want you to notice is this. Look how it's rotating, right? And so by the time it sets over in the west, that's sunset just before morning. Now here we are. Now we're in the west. Now we're in the southwest horizon. The moon has kind of twisted in the sky. And that's just an effective perspective. It's still the same moon. It's still the same amount of the moon that's illuminated. But now that little round circle that was so obvious on the top is now over on the east side. So it depends on the time of night. It depends on where you are on the earth, but it is always the same moon. And I should mention in passing that we only see half of the moon. We never get to see the side that's on the far side from us, because the moon and the earth are the moon is locked in its rotation around the earth such that it turns one time, it rotates one time exactly in the time it takes to circle the earth. And that lockup is called synchronous rotation. It means that we only see one half of the moon at one time. And that's the only time, that's the only half we ever get to see. We did not know what was on the far side of the moon. It's not the dark side, it's the far side, until the space age, when we were able to send spacecraft past the moon and then look back and photograph the far side.
Kelly, here's a question about the moon that I've always wondered. Why does it rise or set at different times?
Oh, very good question. Very good question. Okay, so what I'm going to do is I'm going to go back to today. Okay, and we're going to go.
While you're pulling that up, we've had a couple of people comment and ask what program you're using, and it's
Oh, yes.
Stellarium, which is available at stellarium.org. And you can
That's
yep.
Right.
So it's up here.
Okay, so now let's go a little bit. All right, so the sun set. Let's show you the sun. The sun is down here below the horizon. Get that thing out of the way. Here's the sun down here. I'm going to put the horizon back. So now the sun is just below the horizon, and you see that the moon is generally in the same part of the sky, the western sky, as the sun. I'm going to add one little marking here called the ecliptic. The ecliptic is basically the plane of the solar system. If the solar system were a CD or a DVD, this red line that I'm showing you now would mark the plane of the Earth's orbit. Now, what I'm going to do is I'm going to kind of back away. You see the moon there, right? There's the moon, and the sun's down here. But now, if I go one day at a time, watch how the moon's location shifts in the sky. It's moving away from the sun, farther to the east, and if I take this to extremes, it's marching across the sky. The sun is still down here over on the right-hand edge, and you see how the moon is moving farther away from the sun until about May 7th. The sun will be over here on the right-hand edge, and the moon will be just rising on the eastern horizon. And when that happens, that's approximately the full moon. That motion across the sky, and the reason that the moon rises and sets at different times during the course of a month is because the moon is going around the Earth. And it takes about 30 days. And if you divide 360, that's the number of degrees in a circle, by 30, you get 12. It's a nice even division. 12 is roughly the number of degrees that the moon moves across the sky from one day to the next. And I know that they're all saying, Kelly, I don't know from 12 degrees. How much is 12 degrees? And here's where your body has come in to help you. If you take your fist and clench it and hold it out at arm's length, that clenched fist is about 10 degrees of width in the sky. So if you see the moon in the sky tonight at, say, 8 o'clock, and then you go back one night later at 8 o'clock, the moon will have shifted along its orbit and eastward in the sky by about the width of one fist.
I see. Thanks. I'm going to try that. And that's a fun thing to do with kids, too. A really easy object to spot for everyone to see and be able to go back night after night. And no matter where you are in the world, you can see the moon, and no matter how much light pollution you're facing, the moon is a visible object and a fun way to sort of explore the way that the Earth and the moon work together. So thanks for that explanation. Kelly, we have one last question, and I think this is a good one to wrap up with. A lot of people watching want to share their understanding of the night sky, their passion for the night. And this question comes from Adam on YouTube, and he asks, what are some of your tips for teaching the night sky to a group?
Yeah, that's Adam, thank you very much. I do that a lot. I have to say, teaching the night sky is a lot easier in a dark location. Where you can see something basic like all the stars in the Big Dipper, or you can point out the Pleiades, that star cluster that's low in the west at sunset, and explain that the Pleiades is a cluster of stars, perhaps like the cluster of stars that our sun belonged to when it formed. What I find very useful is to have a green laser pointer. Which allows me to point out things and have people be able to see what I'm pointing at. But if I don't have that, then all I can do is describe the star patterns. And I just want to mention one more time, I do a monthly audio podcast called Sky Tour that you can get at skyandtelescope.org. And I do exactly that. I take you outside and I walk you around the sky. And what I'll do is I'll say, like, okay, here we are. I'm going to get rid of some of these star names. Hold on just one quick second here. Sky. There we go. Okay. I will walk you around the sky and say, let's go back to now. I'll say, okay, you see that it's the night of the 26th, and you see the crescent moon in the sky, and you see Venus right next to it. If you go just below them by about the width of your fist, you'll see a fairly bright star, and that star is Aldebaran. It is the angry eye of Taurus, the bull in constellations. If you draw a line from Venus through the moon and go to the left, you'll run into Betelgeuse. Betelgeuse is a red supergiant star. It's 500 light years away, but it's insanely bright, 100,000 times brighter than our sun, which is why it appears so bright in our sky. And so I can walk you around the sky just by describing the mileposts, the waypoints in the sky, and even in a light polluted sky, you're going to see some stars, and those stars are usually the brightest stars in their individual constellations, and that's a start.
Yeah, that's great, and I think Stellarium is a great way that the app that you're showing us now is a fun thing to become familiar with and practice explaining what's going on. We've also heard some comments from people where the nights are a lot shorter, or maybe they don't have access to the night sky all the time, that will enjoy using Stellarium to sort of explore what's up in the sky. So Kelly, thank you so much for sharing your knowledge with us, sharing that app with us, and walking us through a tour of what to expect out in the night sky tonight and in the next couple of days. It was a lot of fun.
Yeah, thank you very much, Amanda, and thank you all of you who tuned in. I guess this will be archived so that you can sort of follow up afterward, right?
Yeah. Absolutely.
Okay.
You can watch all of the videos for International Dark Sky Week at idsw.darksky.org. There's a schedule tab, and each of the archived videos are linked to each of the presentation times. So go check out all of the videos. And later today, I'll be back with leaders of the International Dark Sky Association. We'll have our executive director, our board president, and board vice president will answer your questions about IDA and our work to protect the night. So once again, Kelly, I just want to say thank you for being here. It's a lot of fun looking through the night sky with you, looking at Stellarium and hearing the stories of the stars and the constellations. We appreciate you being here.
All right. It's just my pleasure, Amanda, and thank you for all your work pulling this together.
It was so much fun. We appreciate it. And we'll be in touch. Thanks a lot.
All right.
Okay, thanks a lot for tuning in, everyone. We appreciate you being here and all of your great questions. Hey, Kelly, one last question. If somebody had a question for you that we weren't able to get to or want to come back to it later, how can they get a hold of you?
So I'm really easy to find. So my first name is Kelly, that's a K. My last name is Beatty, Beatty, kbeatty@darksky.org will get to me, and I'll happily answer any questions.
Wonderful.
Okay. Stump the astronomer.
Something that'll be fun. Okay, well, thank you very much for that information. I hope that you will reach out to Kelly if you have any questions or want to try to stump the astronomer. And thanks once again for being here. Have a great afternoon. Bye-bye, everyone.